All right, so get this. Today we're going to deep dive into how code, like the stuff programmers write, can actually make those large language models, the AI things everybody's talking about better.
Yeah, even at things that have nothing to do with coding.
Exactly. It's kind of wild, right? Like you'd think training an AI on code would just make it good at, well, writing more code.
You'd think so, but this research paper we're looking at today really flips that idea on its head.
The paper's called To Code or Not to Code, Exploring the Impact of Code in Pre-Training. Catchy title, right?
Definitely grabs your attention.
And it was put out by a team over at Cohere for AI. So what's the big takeaway? What'd they learn?
Basically, they found that training these LLMs on a mix of code and regular text, like, the kind of stuff we read every day, makes them better at a whole bunch of tasks compared to models trained only on text.
Okay, but how much better? Like, are we talking a tiny improvement or a giant leap?
Oh, it's definitely noticeable. In some cases, it's a pretty big jump.
Hit me with the numbers.
All right, so for tasks that involve natural language reasoning, like figuring out the logic behind a sentence or paragraph, they saw improvements up to 8.2%.
That's pretty significant.
Yeah, and for world knowledge, like, general facts about history, science, all that stuff, the improvement was up to 4.2%.
So it's like giving these AIs a crash course in, well, everything.
Sort of. And even in those tasks where the LLMs are competing against each other, those generative things where they try to outdo each other, the models trained on code had a win rate that was up to 6.6% higher.
It's a pretty solid advantage.
Yeah,
So I'm guessing it's not just any old code that does the trick, right?
you're absolutely right. The type and quality of the code definitely matter. The researchers actually tested out a whole bunch of different types.
Like what?
Well, they use everything from web-based code, which is the stuff that makes websites work, to markup languages like HTML, the stuff that gives web pages their structure.
Okay, so stuff we see online all the time.
Yep. And they even threw in things like GitHub commits, which are basically snapshots of code development, kind of like a behind-the-scenes look at how programmers actually write and revise their code.
Interesting. So what did they find? Like, was one type of code better than the others?
Well, they discovered that each type had its own unique impact. For example, using those markup languages like HTML and YAML actually led to better performance on natural language tasks.
Wait, really? So learning the structure of a web page somehow helps the AI understand the structure of language.
It seems that way. It's almost as if learning how to organize information in one domain translates to better organization in another.
That's pretty wild. What about those GitHub commits? Any interesting findings there?
Absolutely. Including those commits seemed to give the models a boost, especially when it came to understanding the context around code, the comments, the discussions, the back and forth between programmers as they're solving problems.
So it's like the AI is learning not just from the code itself, but also from the thought process behind it.
Exactly. It's getting a glimpse into how human programmers think and reason.
Fascinating. So if I'm following you correctly, simply bombarding these AIs with tons of code isn't the answer.
Not quite. It's not just about quantity, it's also about quality, and even more importantly, about using the right kind of code for the right purpose.
Okay, so quality over quantity makes sense. But what about this synthetic code they talk about in the paper? What's that all about?
Ah, synthetic code. That's where things get really interesting.
Give me the rundown.
Basically, it's code that's specifically designed for training AIs. Think of it as like the perfect textbook for learning to code.
So it's like a highly curated, super efficient way to teach the AI the fundamentals of programming.
Exactly. It's often highly structured, very precise, and covers a wide range of concepts.
Sounds like a shortcut to AI coding mastery.
It kind of is. And what's really remarkable is that even adding a small amount of the synthetic code during training led to huge improvements, not just in coding tasks, but in natural language reasoning as well.
Whoa, hold on. So even a little bit of this special code can make the AI better at understanding and using human language.
Yep. We're talking a 9% jump in reasoning abilities and a whopping 44.9% boost in coding performance.
Okay, that's seriously impressive. So if I'm working with one of these LLMs, should I just be cramming it full of synthetic code?
Well, not so fast. While a little synthetic code can work wonders, too much can actually backfire. It's all about balance, and that's something we'll dig into in the next part of our deep dive.
Ooh, cliffhanger. All right, I'm hooked. Let's get to it.
So yeah, it's like with anything else, too much of a good thing can be a bad thing. You can overdo it. Even with something like synthetic code, that seems like it should only be helpful.
Makes sense. So what happens if you just go crazy and load the AI up with tons of code.
Well, the researchers actually tested that out.
Really? They just went all in on the code.
Pretty much. They ran experiments where they gradually increased the proportion of code in the training data,
Starting with zero code and then going all the way up.
all the way up to 100% code.
Wow. 100% code. Like, nothing but code. That's crazy. Did it work?
In a way, yeah, but also no, it's kind of complicated.
Oh boy, I have a feeling I know what's coming. It got good at code, but bad at other stuff.
You got it. As they increased that code percentage, the model's performance on those coding tasks just skyrocketed.
So it became like a supercoder.
Totally. But as its coding skills got better, its performance on things like, understanding the real world and reasoning about everyday situations actually started to go down.
So it's like that classic trade-off, like you gain something but lose something else.
Exactly. It's like becoming hyper-specialized in one area, but at the expense of a broader understanding.
So I'm guessing there's kind of a sweet spot, right? Like an ideal balance between code and regular text.
Yeah, and according to the researchers, that sweet spot seems to be around 25% code.
25%. So 1/4 code, 3/4 regular text. Got it. But what if you push past that? What happens if you go up to like 50% or even 75% code?
You start seeing some problems, especially with those world knowledge tasks. Basically, the model's ability to understand and reason about things like history, geography, literature, all that stuff starts to take a hit.
So it's like you're filling its brain with so much code that there's no room left for anything else.
Pretty much. And when they went all the way to 100% code, well, the model basically bombed those world knowledge tasks. It was like it had forgotten how to learn about the real world.
That makes sense, though. If you only feed it code, it's only going to learn about code.
Exactly. It's like raising a kid in a room full of programming manuals. They might become an amazing programmer, but their understanding of the world outside that room could be pretty limited.
Okay, so the takeaway here is to aim for that 25% code mark, and then, I don't know, maybe adjust it depending on what you want the AI to do.
That's a good starting point for sure. But here's the thing, this research was mostly done on models that ranged in size from like 470 million to 2.8 billion parameters.
It's still massive, though.
Oh yeah, those are huge models. But the question is, do these findings hold true for even larger models? Like the ones with billions upon billions of parameters? The real giants of the AI world.
Right, the ones that are constantly making headlines.
Exactly. Because those models are a whole different beast. And that's what we'll explore next. How does the size of the model affect these findings? Do those benefits of code training still apply when you're dealing with those mega models? And are there new challenges that pop up when you're working at that scale?
All right, I'm intrigued. Let's hear it. All right, so we've talked about how adding code can make these LLMs better, but too much can mess things up. And now the big question. What about those mega-sized models? Do these findings still hold true when you're dealing with the real titans of AI?
Right, the big guys. Well, the researchers did look into that, at least to some extent. They tested their findings on a larger model, one with 2.8 billion parameters, and guess what? The good news is that, yeah, scaling up didn't just wipe away the benefits of code, it still helped.
Okay, good to know. So bigger models still benefit from code. But was there anything different about how those larger models reacted to the code compared to the smaller ones?
Yeah, actually, there were some interesting nuances. For example, the improvements in natural language reasoning, while they were definitely still there, they weren't quite as dramatic as what they saw in the smaller model.
So it's not like the bigger the model, the bigger the benefit.
Exactly. It seems like there might be a limit to how much code can help as you scale up, kind of like a point of diminishing returns.
Diminishing returns. Makes sense.
Yeah.
And what about that trade-off we talked about, where too much code can hurt performance on the non-coding stuff? Did they see that with the larger model too?
Oh, absolutely. In fact, that trade-off became even more obvious with the larger model. When they compared a model trained on a balanced mix of code and text to one that was basically force-fed a ton of code, the performance gap on those non-coding tasks was way bigger.
So it's like those bigger models are even more sensitive to that balance between code and text.
Exactly. You got to be extra careful to find that sweet spot when you're working with those big models. It's not just about adding code, it's about adding the right amount and the right kind of code at the right time.
This is getting pretty complex.
It is. It's not a one-size-fits-all situation, and it's not even just about the code itself. It's also about when you introduce it during the training process.
You're talking about those different training phases, like the initial pre-training and then the continual pre-training and then that final cool-down stage.
Exactly. The researchers found that the timing really does matter. For example, they got some of the biggest improvements across the board reasoning, knowledge, code generation, when they included code during that final cooldown phase.
So it's like code isn't just a building block, it's also like a finishing touch.
That's a great way to put it. It's like that final polish that helps the model sharpen its skills in both code and natural language.
All right, so let's bring it all together. If someone's out there trying to train one of these LLMs, what's the best way to use code effectively?
Based on what we've seen in this research, I'd say go for a multi-stage approach. Start with a balanced mix of code and text during that initial pre-training. Then, as you move into the continual pre-training phase, gradually dial back the code and focus more on natural language data. And finally, make sure to include some code in that cool down phase to really fine-tune things.
Got it. Timing, balance, and using the right kind of code at the right stage.
Yeah.
Anything else?
Oh, and one more thing. Don't skimp on quality. Always use the best code you can find, and don't be afraid to experiment a little. Try different types of code, different sources, see what works best for your specific model and the task you're trying to accomplish.
This has been a wild ride. I feel like I've learned a ton about how powerful code can be. It's not just for building software anymore. It's like a secret weapon for making AI smarter.
Absolutely. And it just goes to show that sometimes the best solutions come from the most unexpected places.
And on that note, we'll wrap up this deep dive. If you're itching to learn even more, we've got a link to the full research paper in the show notes. So go check it out and keep on exploring the fascinating world of AI.